Hi, this is Wisebot. Let's do quiz number 31. A tilted, motionless, uniform, heavy rod is shown in figure P111. And it's frictionless, and it's pivoted at its right end. So this is like a bearing here. It can just kind of spin across this freely, but not move in the X or the Y direction. Let's define X or Y directions here. The question is, draw the free body diagram of the rod. And so if you want to find the direction of the reaction force at the pivot, imagine that the pivot pin was removed. The upper portion of the rod would rotate counterclockwise, that's this way, about the end of the rope. So if you could delete the pin in here so this could just slide, I think you'd see that this would pull down, this would keep things kind of moving over, and so this end would start moving this way. And I'm betting, depending on how the strength of this force is versus that force there, that end would either move over and up or over and down. So that means the reaction force needs to counteract that. So it's going to be slightly up like that or slightly down like that. But let's draw a free body diagram. So here's the rod. We're going to cut the rod free. All the forces on it we're going to kind of delete here. You've got a force down here at the virtual end of the rod, let's say. Let's call that F sub C. Let's call that force. I'm going to call that based on the next, that's F of C. Then you've got a point B here. In the middle, I'm going to turn my head so I can draw it right. It's perpendicular to the rod, let's say. And we're going to call that FB. Okay, now, the cool thing about this is that this is a body with three non-collinear forces. So I could say that the force here is somehow, well, it's got to be this way, because as soon as that pin gets free, it gets pulled free. Let's call that Fx, and we've got an Fy here, Fy. That's the most general kind of depiction of the free body diagram, where when you break a pin, you basically have forces that could go in either direction. I think it's fair to say that this bearing here is providing a force, or could provide a force in those two directions. But the thing we learned in the chapter is that all these forces have to make a triangle. So if you have F sub C down, in other words, they all have to meet at a point. That's one claim we made in the chapter. So here's F sub C down. Now let's just draw the forces kind of isolated from each other. This is a F of B over. I'm trying to get it just right here. That means, oh, sorry. We're not drawing tip to tail. Yeah, we're drawing tip to tail. We're not drawing from a single point. So this is F of B here. Then I think you can see that F, the combination of F of X and Y, has to have some component in the X direction and some component in the Y direction. So this is why the sum of the forces equals 0. Now, the extra credit part, here's my hint. This I call point A, this I call point B, this I call point C. Sum the moments about point A, and that has to equal 0. And then sum the forces in X and sum the forces in Y, those also have to be equal to 0. From those, you should be able to find f of b and the combination of f of x and f of y. So give that a chance, but this was this point in the book that says that any free body that's got 3 forces on it, the forces have to meet at a point. And I think you can see this point. If this is coming back like this, and that's going up like this, I think you could see that the point could be somewhere in this area here. So you could move that force over. It has to be at a point. Okay, so that was quiz number 31. Kind of easy, but I wanted to give an example of that, that 3 forces on a single body